Okay, Assalamualaikum. My name is Nur Ida Mazrin from Group 2, and today my teammates and I are going to present about the waste management in the seafood industry. Next. Okay, so this is the list of my team members: Zila, Ida, Nani, and Aida. Next. So this content for our presentation. I will start off with the introduction to seafood industry, followed by knowing the types of waste produced by one of the famous seafood industry, which is the surimi industry. And then we will look on how the waste will manage, and we will wrap up with the advantages and disadvantages, and also some recommendations. Next. Okay, so let's start our presentation with the introduction to the seafood industry. So the total production of seafood in the world is in 2018 was 178.5 million tons, of which 96.4 million tons and 82 million tons came from the catch fisheries and also aquaculture respectively. So with an increase in the world population, which is anticipated to reach 9.8 billion in 2050, the demand for the seafood is predicted to surge by 60%. So next, in the point 3, with the increase in the seafood industry sector, which is the marine and aquaculture, it will lead to a heavy amount of waste produced, and it is estimated that almost the same amount of seafood eaten per ton is wasted. So which means the amount of seafood that we eat is the same as the amount of waste that will be produced. So the waste from seafood mainly came from the centralized pre-processing operations, for example, beheading, deshelling, skinning, and gutting. So with the total of big amount of waste produced by seafood industry, in this presentation, we will discuss about how we can manage the waste that came from this industry. So next slide. So this is the type of waste produced by the seafood industry as a whole. So we have two types, which are the solid waste and also the liquid waste. And solid waste is mainly comes from the centralized pre-processing operations such as beheading, shelling, skinning, and also gutting. So examples of waste are heads, skeletal frames, skins, and also scales. Next is the liquid waste. Liquid waste is the water that was discarded during washing, chilling, blanching, filleting, cooking, and etc. So examples of waste, which is known as effluents, are bloody water, wash waters from cutting stages, cutting, and also filleting. So the total suspended solids are also in the wastewaters, such as myofibrillary proteins, collagen, gelatin, enzymes, peptides, and also amino acids. Next slide. So one of the seafood industries is the surimi industry. So surimi is commonly used in the food service and also food manufacturing industry to prepare seafood such as crab steak, fish steak, and also crab flakes. So this slide highlights the waste that is produced in the surimi waste during its processing. So the first one is during filleting. It involves in the removal of head, skin, internal organs, and also bones. Next is during washing after filleting process, which involves the removal of bloods and also other impurities. During washing cycle 1, 2, and 3, and they involve the removal of blood, lipid, and also sarcoplasmic protein. And lastly, during pressing, it involves removal of excess water. Next, I will pass to the next presenter.
Okay, so I will continue with the two ways on how to handle seafood product waste, which are the wastewater treatment and solid waste treatment. Next slide. Okay, so for the solid waste treatment, it includes skin, fish heads, fish bones, and scraps of flesh. So the first one is composting. So basically, composting is a natural process that turns organic material into a dark-rich substances called compost, which is a wonderful conditioner for soil. And it is a aerobic biological breakdown. And for example, the fertilizer, its nutritional composition of fish waste allows to supply plant nutrients or to enrich a compost. So in the figure on the right side is indoor method of composting. The next is fish silage. It is an autolysis of fish waste held under acid conditions, and it requires branding fish, adding formic acid to it, and mixing. So basically, we can see from the figure below. For the additional information, canned pet foods are produced by processing tuna and salmon waste by many of the largest seafood industry. Also, shellfish waste could be used to make calcium lactate and protein hydroxylates, which may be used to improve animal feed. And the last one, dry and ground fish molecules is used effectively as organic wastewater coagulant. Next slide. Okay, so the next way is wastewater treatment. The first one is primary treatment. It is recommended prior to a biological treatment process for an optimum waste removal. And it's remove up to 85% of the total suspended solids and 65% of the BOD and COD present in the wastewater. The first one is screening. It is a removal of relatively large solids, which is 0.7 mm or larger, and it divided into two, which are rotary drum screening and tangential screening. The second one is sedimentation. Sedimentation is separation of solids from water using gravity settling of the heavier solid particles. And it's divided into three, which are flocculant suspension, discrete settling, and zone settling. So the next slide, I will pass to the next presenter.
Okay, I will continue the presentation with biological treatment. So biological treatment involve the use of microorganisms to remove dissolved nutrients from a discharge. Organic and nitrogenous compound in the discharge can serve as a nutrient for rapid microbial growth under aerobic, anaerobic, or facultative condition. And most of the microorganisms that presents in wastewater treatment system use the organic content of the wastewater as an energy source to grow and are thus classified as heterotrophs from a nutritional point of view. And microorganisms present use okay, so the first type of treatment for the biological treatment is aerobic treatment. In seafood processing water, the need of adding nutrients, the most common being nitrogen and phosphorus, seldom occur, but an adequate provision of oxygen is essential for successful operation. And the most common aerobic process are activated sludge system, lagoons, trickling filter, and rotating disc detector. The reaction for aerobic treatment are like shown in the equation in the slide, which it produce cells carbon dioxide and H2O. And the second treatment for biological treatment is an aerobic treatment. And aerobic biologically treatment has been applied to high BOD or COD waste solution. And this treatment usually produce carbon dioxide and methane. And the treatment are reported to be better applied to high strength wastewater, for example, like blood water, and seawater.
Okay, so next we will move to the third method, which is the physicochemical treatment. And for the physicochemical treatment, it consists of coagulation or flocculation process, which is to improve the treatability of wastewater. So there are several steps involved in the coagulation process. So the first one is the coagulant is added to the effluent and mixing proceed rapidly with high intensity. The second stage follow, in which flocculation occurs for a period of up to 30 minutes. In the latter case, the suspension is stirred slowly to increase the possibility of contact between coagulation particle and to facilitate the development of large floc. And then these floc are then transferred to a clarification basin, in which they are settled and are removed from the bottom while the clarified effluent overflows. So here we can see the process of the coagulation. And the byproduct is the recovered sludge from seafood industry may be added, which is the non-toxin. And for the another marine byproduct that can be used as coagulant is a natural polymer derived from chitin, which is also known as chitosan. And the next step is disinfection, which is the function to destroy the disease-causing organism. So the chlorination is a process commonly used in both industrial and domestic wastewater for the disinfection method, which consists of
chlorination vessel in which the wastewater and the chlorine are brought into the contact. So in order to provide sufficient mixing, a chlorine system must have a chlorine contact time of 15 to 30 minutes, after which is must be chlorinated prior to discharge. Okay, next. Okay, so for the advantages and disadvantages of the method that we are explained before, so for the composting method, the advantages is it can improve the soil fertility and its water holding capacity, and the disadvantages is it labor and cost expensive. And for the sedimentation, it has a low cost of designing and constructing, and also low technology requirement for the operators. And the disadvantages is need a lot of space, design based on a maximum volume. And for the chlorination, it is inexpensive and readily available, and it also a powerful oxidizing agent, but it is a volatile content, and also it has a disinfection byproduct, DPBs. Okay, next, I will move to the recommendation.
Okay, so this is the recommendation for waste treatment for seafood industry. The first recommendation is to reduce the restriction to develop sustainable production methods that will not put the environment at risk. The second recommendation is the stringent rules should be imposed on seafood waste disposal by the government of different nations to promote the use of this invaluable waste industrially. And the last recommendation is to use the using of pond system in aquaculture farming to maintain at a level that will not be toxic to fish. And I think that is all from us. Thank you.